This is the video presentation for the part 2, where the study about above causal case is presented using Jupyter Notebook. Here, linear discriminant analysis is done with Pokemon stat datasets. This is the dataset for the Pokemon. It has many attributes, as you can see. And the total data is 802. Let's see the data. Analysis with Pokemon stats. At first, we're importing Panda as PD, and then importing the dataset, which is Pokemon.csv. Here we can see the head with 3 numbers. As you can see, we have seen 3 rows and we have 41 columns and 41 attributes, different attributes. Here you can see type 1 grass, 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 type 2 poison, poison, weight. These are all the attributes of the Pokemon stats. Now we are normalizing. Normalization is used, which is pre-processing steps. Here the type 2 attribute to column and the attribute SP attack, SP defense, attack defense speed has been normalized. The value of the normalized data is set in x norm underscore norm, and for the y and the another values is stored in y, x and y. Here the linear discriminant analysis with 3 components is executed here, and after this we can see the plot with the linear discriminant analysis LDA feature coefficients. Here we can see the bug, dark, dragon, electric, fury, fighting, fire, flying, ghost, grass, ground, ice, normal, poison, psychic, rock, still, water is in the left, and the bottom is SP attack, SP defense, attack, defense, speed, and SP. And again, we're showcasing the linear discriminant analysis LDA class coefficient sums. Here you can see the difference between the rock and the ghost is pretty huge, where the ghost is less than 80 and the rock is more than 100. So that's a very big difference. And here with the fire and ice. As you can see, the both are under 20, so the difference is not that much. So now the three explained variants of linear discriminant analysis decomposition is showcased with three variants: 0.48, 0.21, 0.130. After this, the two-component linear discriminant analysis LDA decomposition has been plotted. As you can see, we have C1 here and C2, and all the different colors is the representation for each showcased here. Blue for bug, dark for the gray, dragon for the orange, yellow for the electric, the red for fire. As you can see, fire, red, 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 blue. The pink is for the flying, and so this is the showcase of linear discriminant analysis with Pokemon stats. The conclusion is as following. The linear discriminant analysis LDA in depth is presented. LDA is a dimensional reduction technique which is a first tool of choice when working with classification tasks. As an EDA technique, it tells us a lot about the complexity of our problem and tell us which classes are most easily distinguishable and why. As a pre-processing technique, it improves model performance for any useful model we apply to the dataset afterwards, but particularly for linear ones like SVMs.